Hello. Hello, students.
Hi, sir.
Shall I continue?
Yes, sir.
Okay. Here, to see, this is
मेरा मेरा माइक माइक भी ऑडियो बंद कर खाली मैं नहीं
okay. Shall I start here? Here we have two. One is the theory paper, and another one is the practical. Okay. Here, one is the theory paper, another one is the practical paper. Have you able to hear, students?
Yes, sir.
Okay, shall I continue? Okay, here you see in mathematics we have two. One is the theory paper and another one is the practical paper. You see here the first one. Have you able to share the screen also? Have you able to see the screen?
Yes, sir.
okay sir okay
Okay.
Yes,
Here
sir.
you see the theory paper. The name is Algebra 1 and Calculus 1. Okay. Here you see here the Algebra 1 and Calculus 1. That is the theory paper. And the second one is the practical. That is practical 1 is there. Okay. And here you see
sir
4
this is practical
for practical is there. And here the credits are 4 credits for theory and 2 for practical. Okay. The number exam duration is 3 hours for the theory paper as well as practical paper. And here you see
okay sir
that the internal marks for the theory 20 is there, for the practical you have 10. And then here you see here you see the total maximum marks per theory is 80 and the internal is 20. And then for the practical you have for 10 is the internal marks and 40 is the exam you have to attend for the practical. Okay.
Yes, sir.
Now here the paper is algebra 1 and calculus 1. Totally you have, this is the theory paper, and here you have four chapters are there. First one is the unit 1 is the matrices, unit 2 is the system of linear equations, and unit 3 is successive differentiation, and unit 4 is the differentiability of functions. Here I am starting with the successive differentiation. Okay, I think you got the idea here. Algebra 1 and calculus 1 means first two are the algebra, second two are the calculus part. And then here you see I am starting with the successive differentiation, that is unit number 3 I am taking here. Okay, have got the okay, have you got the idea? Here you see
Sure.
two are, that is matrices, system of linear equations is for the algebra, successive differentiation, differentiability of the function is the calculus. Okay. Now here you see the books for reference are there. You can get the syllabus from the Gulbarga University. And here you see the practicals. Totally there are 12 practicals are there. You see this is the practicals 1. That's right. Okay. Now here you see the practical papers. There are 12 practicals are there. First one is the sum difference product. Then computation of trace and transpose of the matrices, etc. is there. And then computation of rank of matrix. Here totally we have 12 practicals are there. Okay. Now first one is the theory and second one is for the practicals. Here you see here we got here 40 marks is for the practical exam. That is we have to attend physically, and here you see internal marks is for 10 marks. Okay. And already you have taken the previous one, that is theory paper. You have seen that there you got here 80 marks for the theory and 20 is for the internal. Okay. And here you see the practicals. Practical, there are two softwares. The one is the Maxima and the second one is the Scilab. Here we are using only the Maxima here. In the Maxima, these two are the open sources. You can collect from software from the online. Okay, maxima, scilab, these two. Here you are using only the maxima, but the both you can use for the practicals to solve the practicals. Okay, these are the paper practicals, and you can use either maxima or scilab you can use. And in our college we are using only the maxima. Okay, and here this is the pattern of the question paper for all 4 semesters. For fifth and sixth it varies. Okay, here you see here the first four sems you got the same pattern. Unit one, one, two, three questions are for the unit one. Unit two is so say 4 to 6. That two marks is there for each. You see here 10 into 2 20. Total you have 12. Out of 12 you have to write 10. And one first three is from unit one, second three is from unit two, and then the three are from unit 3, and the remaining 3 are from unit 4. Okay, that is totally 12. You have to write 10 out of 12, and we are getting 20. And the second question is here you see 5 marks questions are there. Totally you got 4, your second, third, fourth, and then fifth is there. You see here in the second one, here you are going to get 4 questions. You have to write any 3 into 5 50. Similarly for the remaining unit 2, unit 3, unit 4, so the same pattern will be there. But for fifth and sixth it varies. Okay, don't bother about that one, fifth and sixth. But here you concentrate only on the first semester. Okay, here this is the pattern of the question paper. Okay, this is the pattern of the question paper. Okay, now I think you are able to see the screen. Is it not? Have you able to see the screen?
Yes, sir.
No? Have you able to see the screen?
Yes, sir.
Okay, sir.
Okay. Successive differentiation. Okay, here the screen will be. And I'm already told to you, I'm starting with the unit number 3, that is successive differentiation. Successive differentiation. Okay. Just wait. Okay, let it be. Okay. Okay. Are you able to see the screen? Hello, listeners?
Yes, sir.
Okay. I will start further. Now you see, already you are studied in lower classes the successive differentiation. The meaning of successive differentiation is the process of obtaining successive derivatives is called successive differentiation. Okay. And here you see, if y is equal to f of x is continuous, then you are going to get dy by dx, and that is called the first derivative of y with respect to x. Okay. That is called the first order derivative. Okay. Now here if it is continuous, that is dy by dx is continuous, then you are going to get the second order derivative, that is given by dy by dx of dy by dx. Again that is continuous, then you are going to get the third derivative, and similarly the process will continue. And here you see dy by dx of, if you take n minus 1th derivative of y, you are going to get the nth derivative. Okay, now just you remember here, you are going to get y1 first. They will give the y, you have to differentiate with respect to x, and you have to get y1, y2, y3, and then you have to generalize and you have to write the nth order derivative. Nth order derivative. Okay. Now, just you remember here, the process of obtaining successive derivatives is called successive differentiation. That is, we have to get first y is given, we have to go into get dy by dx, dy square y by d cube y by dx cube, so on. The nth derivative you are getting, that is called, the process is called successive differentiation. Okay. Now, the nth order derivative, that is yn, that is y equal to f of x is given, then you are going to get the nth derivative notation, that is d to the power ny by dx to the power n, or d to the power n of y. You see here, just I am showing the cursor, you follow the cursor, you see y to the power n you are writing here, yn you are writing. Normally you are using here, yn you are using here. You see this you are using here, okay? Or f1, fn of x or d to the power n f of x. These are the notation for the nth derivative. Okay, these are the notation for the nth derivative. Now, if suppose x to the power 4 is given, that is equal to y, if you differentiate, you will get 4x cubed. And then if again if you differentiate, you get 12x square d cube y by dx cube means again if you differentiate, already you know x to the power n means you are writing the derivative of that is equal to n x to the power n minus 1. Okay, d cube y by dx cube, then d to the power 4y equal to 24, then you are getting here which is equal to 0. Now this is the, you see here y is given, we are getting dy d square y by dx square d cube y by dx x. The continuous you are getting is called, the process of getting the derivatives is called successive derivatives. Here y equal to is given, that your what you got dy y1 y2 y3 y4 y5, these are the successive derivatives. Okay. Now, calculation of nth derivative of some standard functions. You see here, you are going to get the nth derivative. What is this? Okay. Here. Okay. Here, calculation of, just wait here. Okay. Here, calculation of nth derivative of standard functions. That is, you are taking the some function y is equal to, and then you are going to get the nth derivative. And here, y is equal to e to the power ax. Y is equal to e to the power ax. For this, we are to get the nth derivative. Okay. Here, y is equal to e to the power ax is given, that is y, we have to find out the nth derivative of e to the power ax. Okay, differentiate this with respect to x, so that we are going to get the first derivative, that is y1 equal to a e to the power ax, because you see the derivative of e to the power mx is given by e to the power mx into the inner derivative mx. If you differentiate, you are going to get m, that is you are given e to the power mx into m. Same way, if you differentiate here, e to the power ax into a, you will get that you are writing as a e to the power ax. Again, if you differentiate this with respect to x, because I'm already told to you, first you are going to get from y, you are going to get y1, then y2, then y3, then afterwards you are generalizing and you are writing the nth derivative. Okay. Now, after getting y1, again differentiate that with respect to x, so that you are going to get the second order derivative y2, that is equal to a into a e to the power ax, because you see here you have got a is there, a you are writing separately, there is a constant you are writing outside. The term that is containing e to the power ax, if you differentiate, you are going to get here a e to the power ax. Now a into a is a square into e to the power x you are getting. Now similarly, again if you differentiate, you are going to get y3 equal to, here a square is the constant you are writing outside, and if you differentiate e to the power x, you are going to get a e to the power x. Okay. Now A square into A is A cube e to the power ax you are getting. Now you got from y, y1, y2, y3. You see here a to the power nothing is there, that you can write as a to the power 1. Here y1 is there, here you are getting a to the power 1 e to the power ax. Similarly y2 is there, you are getting here a square, you are getting e to the power ax. Y3 means a cube. Suppose if you replace 3 by n, how much you are going to get? You see yn equal to e to the power n into e to the power ax. Now what you are getting? The nth derivative you got here by observing y1, y2 and y3 you are getting yn equal to so and so. Now what you got here? The nth derivative of e to the power x equal to a to the power n e to the power ax. Okay. Now this is the nth derivative. This is the process. First y they are given, then you are getting differentiating, you are getting y1, y2, y3, then you are generalizing and you are writing yn. Now you got the nth derivative of e to the power ax equal to a to the power n into e to the power ax. Okay, that is now the first one is over. We have to remember this for to do the problems. Okay, now the second one, here y equal to a to the power mx is given. We are going to get the nth derivative. That means we have to differentiate with respect to y with respect to x, and you have to get y1, then y2, then y3, then we have to generalize. Here you see y1 means y is a to the power mx. If you differentiate with respect to x, you get a to the power mx as it is, you write, because you see d by dx of a to the power x equal to a to the power x into log a. You see here, instead of x you have a to the power mx is there, and the log a you can write as it is. Now the inner derivative is d by dx of mx. With respect to x means you get here m into 1 is equal to m you are going to get. Now here this is you are getting as m. Now what you got? M log a into a to the power mx. Okay. Now again you have to differentiate. Of course here nothing is there means you can write that as to the power 1. Now differentiating again with respect to x to get y2. Now y2 means already you have m log a. M is a constant, a is a constant, log a is also a constant. You can write m log a outside. Now what you have to differentiate? Only the term containing x. Here a to the power mx is there. If you differentiate a to the power mx, we are going to get what? Here already are taken that is why you got here a to the power mx into m log a to the power mx you are getting here. The same you are writing here. You see this is equal to this much. You see y1 equal to. Now you see m log a into m log a is m log a whole square into a to the power mx. Okay. Similarly, if you differentiate, you see m log a to the power 2 is a constant you are writing outside. Now if you differentiate a to the power mx, you are going to get the same what you got in y1. You are rewriting the same m log a into a to the power mx. Now if you simplify here, m log a whole square is there, m log a is there. Already you know a to the power m into a to the power n, you can write as a to the power m plus n. By using that here, you can write m log a to the power 3 into a to the power mx. Now you got y1, y2, y3 from y. Okay. Now in general, yn equal to, you see here y3, y2 means how much you got here? Y2 equal to m log a to the power 2 into a to the power mx you got. And that means wherever 2 is there, here 2 is there, you are writing here 2 you are getting. Here 3 is there, you are getting here 3. Here you are getting 3. Here you are getting 3. And similarly if you replace 3 by n, you see here y3 is there, we are getting yn, m log a to the power, you are getting 3. And that means yn equal to log a to the power n into a to the power mx. Okay. Now the nth derivative you got here, the nth derivative of a to the power mx equal to m log a to the power n into a to the power mx. By observing y1, y2 and y3 you are writing this. Okay. Now because you see y1 you are not written here 1, but that is understood, y1 equal to m log a to the power 1 into a to the power mx. Similarly y2 equal to m log a square, here m log a to the power 3, m log a to the power n, the nth one. Now this is the nth derivative of a to the power mx. Now we will see the next one, that is y is equal. Here there are different cases will arise within this, and this is the generalized one. After we are going to get the particular cases from this ax plus b to the power m. Now differentiating with respect to x, ax plus b. This is first one is e to the power m, e to the power mx we are taken. The second one is a to the power mx. Now the third one is y is equal to ax plus b to the power m you are getting here. And if you differentiate with respect to x, we are going to get y1 equal to, already you know d by dx of x to the power n is how much? That is equal to n x to the power n minus 1. If you apply the same here, you are going to get m into x plus b to the power m minus 1. Now the inner derivative you are going to get here d by dx of x plus b means inner derivative is with respect to x plus you are going to get a. Now what you got here? M into ax plus b to the power m minus 1 into e. Now Again, you differentiate this with respect to x so that you will get y2. Okay. Now, if you differentiate this with respect to x, y1, if you differentiate, you will get y2. Now here again m is a constant. You can write m as it is. Now ax plus b to the power m minus 1 here apply the formula d by dx of x to the power n, so that you are going to get here m minus 1 into x plus b to the power m minus 2 into yes, a you are getting here 1a is already there. A into a is a square, because inner derivative is you are going to get a, already 1a is there. If you do multiply, you get a square here, directly they are written here. Now similarly y3 equal to, now m into m minus 1, here two terms you got here, 3 means you got 3 terms, m into m minus 1 into m minus 2. If y4 means m into m minus 1 into m minus 2 into m minus 3 into, you will get here. Similarly here, see y2 equal to a plus b to the power m minus 2, you got here a plus b to the power m minus 3. Here a square you got here, y3 is there, you got here a cube. Okay, y3 means 3 components, m into m minus 1 m minus 2 ax plus b to the power m minus 3 into a cube. By now you see y1 you got, this is the y1 and this is y2 and this is y3. Now from y1, y2 and y3 you are going to get yn. Okay, here you see here m minus 2 is there, you are writing m into m minus 1 m minus 2 so on to m minus n minus 1 ax plus b to the power m minus n into a to the power n you are writing, because you see here 3 means here minus 2 is there, that's why you are writing here m minus n minus 1. Okay, now the nth derivative of ax plus b to the power m is equal to how much you got here, yn, in the sense already you are taking the notations. What is that? This d to the power n y equal to here ax plus b to the power m. Okay, now m into m minus 1 into m minus 2 so on to m minus n minus, the same you are writing here, instead of yn you are writing d to the power n of that you are writing. Now the above result is true for all values of m, that is above result is true for all values of m. Now we will get the particular cases, we will get the particular cases. You just see one by one here. You see one by one. First case is when m is equal to n, a positive integer. Now the equation 1 will become, you see wherever m is there, that you replace by n, or you can write m also, you can write there, no problem, because m is equal to n, either you can write m or you can write n. Now you see this is the first one. Now the nth derivative of x plus b to the power n equal to, wherever that m is there, you are replacing by n, so that you are getting here n minus 1. Yes, you replace here m by n, so that you are getting here n into n minus 1, n minus 2, so on to 1 into a to the power n. Now already you know n factorial means what? N factorial equal to, you are writing n into n minus 1, n minus 2, so on to 3 to 1 you are writing here, that is equal to n factorial a to the power n. Now if you take a is equal to 1, so that you are going to get the nth derivative of x to the power n equal to n factorial, because you see here ax plus b is there, you take a is equal to 1 and b equal to 0, and if you substitute, you will get here nth derivative of x to the power n equal to n factorial. Okay, now case 2, that is first one is m is equal to n. Now m is a positive integer and m is greater than n. Already you are taken number 1, the same you are writing here, equation number 1 is, this is the equation number 1. Now the same you write here m into m minus 1, m minus 2 and so on to m minus n plus 1, and if you subtract minus 1, you will get here m minus n, m minus n minus 1, so on to 2 come 2.1 into a to the remaining is same, there is no changes, but here this you are writing extra. What is that? M minus n into m minus n minus 1, so on to 2 into 1 you are writing extra. Because you are writing extra means the same you have to write in the denominator, because if you cancel these two, you get the original one. Okay, now the same you can write as the numerator will become m factorial and the denominator will become m minus n factorial, and the meaning is same. The formula we are getting here again the same way. The particular case you are going to get here, you take a is equal to 1, b equal to 0, so that you will get here nth derivative of x to the power m equal to m factorial by m minus n factorial into x to the power m minus n. Now case 3, first one is m is equal to n and m is greater than n is the second case. Now m is a positive integer, m is less than n. Now you see nth derivative of x plus b to the power m equal to 0, because you see n is greater than m, that's why you are getting here 0, because the nth derivative of this is equal to x plus b to the power m equal to m factorial a to the power m. M factorial is you are getting some value, a to the power m is also some value, therefore that is equal to constant you are getting. Now if you differentiate further, that is d to the power m plus 1, m plus 2, m plus 3, whatever may be, is this will become zeros. That's why here d to the power n x plus b to the power m equal to 0. Now, if you put A equal to 1, B equal to 0, you get the particular case that is equal to 0 when n is greater than m. Okay. Yes, the particular case we are getting here A is equal by taking A equal to 1 and B equal to 0. Now, case number 4. Now, first one is m is equal to 1, second one is m is greater than n, and third one is m is less than n, and here you are getting m is equal to minus 1. Now, you see from 1, if you substitute the value, actually you are getting here a plus b to the power minus 1 you are getting here. Now, if you replace that m by minus 1, you are getting this minus 1 into minus 2 into minus 3 so on to minus n. Now from each component you take minus 1 as common. So that how many here to here n terms are there? You can write minus 1 to the power n. Now what is the remaining? 1 into 2 into 3 so on to n is there, that you can write as n factorial into a to the power, because n factorial equal to n into n minus 1 so on. Now if you move here to here you get the same, that's why you are writing here n factorial. Now the remaining is same, you are writing a to the power n, and this you can write as ax plus b to the power n plus 1, because a to the power minus m you can write as 1 by a to the power m. Now the fifth case, when m is a negative integer, where m equal to minus k being a positive integer. Now d to the power n, ax plus b to the power minus k, because ax plus b to the power minus m is ax plus b to the power m is there, you are writing m equal to minus k, that's why you are writing here the same. And here you are getting 1 by a to the power minus m, you can write as 1 by a to the power m, same you are written here, and you replace that m by minus k, so that you are getting this. Okay. Now again in the same way, you see here you got minus minus, you take from the n components, take minus as common, you get minus 1 to the power n. Now what is the remaining? K into, if you remove minus from each bracket, you will get here k into k plus 1, k plus 2 so on to k plus n minus 1, by removing that minus from each bracket. Now what is the remaining? A to the power n divided with x plus b to the power k plus n. Now here you got, here you have to make some rearrangement here. After here just you add 1, 2, 3 so on to k minus 1, and denominator also you add the same, because you have to get that generalized one, that's why you have to add here to here. K means that before term is k minus 1, and here k minus 2, k minus 3 so on to 3 to 1 you are getting here, and the denominator same, what you are writing in the numerator the same you have to write in the denominator. Okay. Now the numerator will become k plus n minus 1 factorial, denominator will become k minus 1 factorial. This is, you have to rearrange the terms and you have to write here. Okay. Now you put a is equal to 1, b equal to 0, so that we get here the derivative of 1 by x power k equal to so and so. Okay. Here this is the cases. I am stopping here itself, and remaining we'll see in the next class. Okay. Hello. And the reference for this book is I am using
Okay,
the
sir.
Mahantesh Swami book. I am used as the reference book. This reference book I got from the
Sir,
Mahantesh.
good name, sir. Sir, question paper send me, sir, WhatsApp.